Our first presentation this morning is by Russ White from Ericsson, and he'll be discussing Rethinking Centralization.
So, if anybody's seen me speak before, you know how much I love podiums. Just awesome. Thanks, Tony. This is your obligatory trigger warning. There are things in this presentation that might get you upset, but that's okay. I'm used to that too. Did anybody bring tomatoes? Okay. All right, good. I'm pretty safe then. All right. So I'm Russ White, work for Ericsson right now. Old Redback. You probably know Redback better than you do Ericsson. Does Ericsson even make IP product? Anybody on an Ericsson router? Probably not. Oh, look, somebody. Oh, 2 people. I'm astounded. Anyway, then you can skip to the next slide. Or is there a thingy up here? Here we go. All right. So first of all, note well, this is an experimental presentation, which means I may change my mind about what I'm talking about in the middle of the presentation or look like the dog before it's over with. So that's great. All right. Does anybody recognize this? Okay, I've lived through this. You know, I started in IT putting VT100 terminal cards in little Zenith Z100s, and then I moved up to Z248s, which is that bottom bottom one down there, and then on and on and on. You know, we do mainframes, then we do let's do Lotus 123, then we do minis, and we do SQL, and then we play all these games. We have been doing this in the IT industry for a very, very long time. Tony and I were just talking, Tony was just saying that we do this organizationally as well. And I think we're actually doing this in the control plane as well. This presentation is primarily about the control plane. So why do we do this? First of all, we look around and we say, okay, you know, this centralized stuff, this polling from the old mainframe days, it's really complex and it's really slow. It takes 5 minutes for somebody to figure out that VT100 is offline. It's a bad thing. We need to make this faster. Wouldn't it be cool if we decentralized and we did something like routing protocol, that's it, ISIS, OSPF, BGP. We could do that and decentralize our control plane, be really cool. And then we distribute it and we all look at it and go, oh my gosh, this is really hard. Routing is not a solvable problem. Let's do software-defined networks and OpenFlow and bring it all back into the center again. The other reason I think we do this is because we have this whole CapEx cycle that we're playing with. When you buy a data center, you buy all the links and all the fiber and everything else, and then you start using it, and 10 years later, you actually use it to full capacity. And by the time you've used it to full capacity, you've already run out of end of life for all of your equipment. So you actually have this huge CapEx waste between what your business requirements are and what you're actually trying to do. I think there's a couple of reasons we play this game. Either way, I think it's a bad thing. In the end, I think what we're trying to do is we're actually trying to solve complexity. You know, the whole CAP theorem, anybody know what the CAP theorem is, right? And consistent, available, and partitionable. The entire quick, cheap, and high quality problem that you run into, all of these little side effects of Turing proofs that exist in the real world that we face on a daily basis. I think part of what we're trying to do is we're actually trying to solve complexity. And there's no silver bullet for complexity. You know, we think that distribute is too complex, so we centralize. We think centralize is too complex, so we distribute. So here is what I feel like a lot of times. There is no silver bullet for complexity, but there is that stupid pendulum on the bottom of that clock, and we keep centralizing and decentralizing things constantly, and it's driving me mad. There are several things in the IT industry driving me mad right now. If anybody reads my blog, you'll hear all about the things that are driving me mad. So here's a radical thought. Has anybody seen this video? I love this video. Stop it. Okay? Stop it or I'll bury you alive in a box, as he says at the very end. See, somebody's seen it. So anyway, stop it. We are driving ourselves nuts. We are playing lots of games with 5,988 types of tunneling, 4,000 different types of control planes and overlays, and all because we're trying to solve an unsolvable problem. Complexity can't be solved. You can mitigate it, you can live with it, you can figure out how to work around it, but you cannot solve this, okay? I had somebody tell me the other day that the CAP theorem is just an observer theory, and I thought perhaps they needed to be under observation. So, Where do we go from here? I feel like I'm in an MC Escher drawing, right? There's staircases everywhere. I can't figure out which way is up. I'm just running around doing stuff. So let's think about this. How do we solve this in other parts of the network? How do we mitigate complexity, or how do we manage complexity and understand complexity and deal with it in other parts of the network? That's not my dog. My dog is at the very end. I'll tell you when we get there. But anyway, right? What do we do in protocols? We layer protocols, right? We have this infamous 7-layer stack, the 7-layer model, which is so far dead and so far out of bounds of useless that I don't even explain it to people anymore. But anyway, but we do layer protocols. We layer protocols because we simplify protocol design, right? What we do is we look at it and we say, okay, I can create consistent and understandable APIs, and I can split failure domains by layering protocols, right? I can take my protocol and I can split different things from one another. I can divide complexity from complexity and build things between them. Here's a more efficient model for understanding layering protocols. I don't know if anybody's read John Day's book, Patterns in Network Architecture, but this is the model he pushes through, or he iterates through, this iterative model. So you can see there that if you look at what the functions of a protocol are, you have effectively 4 things that you're doing. You're doing transport, or marshalling, as we used to call it in SQL days, right? We marshal our data. We have multiplex, we have error correction, and we have flow control. Those are the 4 things we effectively do with a protocol. Those are the 4 purposes of a protocol. We can actually look at this and say, okay, Ethernet does transport multiplex, data link does error flow control, then IP does transport multiplex, TCP does error flow control. So if I actually look at this, I can start looking at this and saying, what I've done is I've divided my purposes, or what I'm trying to do, and I've figured out how to divide them up into a way where I have clean APIs, and I have clean separation of duties, and I've actually separated hop by hop and end to end in my network. And then I go up to HTTP and I transport all sorts of garbage over HTTP and BGP, and then I just keep building these layers for no apparent reason other than I can, right? So that's basically what we do. All right. We layer topologies. All right, I've been writing about hierarchical network design since the late 1990s. First book I wrote, Advanced IP Network Design, was all about hierarchical network design. It's a cool idea. It doesn't always work in all real-world networks, but it's a cool idea. But even if you don't do pure hierarchy, you still do some sort of layering of topologies. And why do we layer topologies? Because we simplify the problem space, right? We take our data center, and it has one set of problems. I have a WAN, and it has a separate set of problems. I separate these 2 things out, and I break up the failure domains, and I make it easier to troubleshoot within each failure domain by separating my purposes and what I'm doing. We layer lots of other things. Okay, why did we first start running BGP? It was to divide my customer routes from my internal routes. That's what I cared about. We do it a lot. We do a lot more stuff with BGP today. Or does anybody think we'll be soon transporting video over BGP? Because we've just about thrown everything else that you can imagine in the protocol. We might as well just add video and get it over with. Anyway, but the original reason for using an EGP was to keep my customer routes separate from my routes. Hierarchy, right? Again, reachability aggregation, repeatable configurations, right? I modularize my network so I can do repeatable configurations. I do failure domain management. I really care about these things. Flooding domains, right? Why do I break up flooding domains in OSPF and ISIS? Because I'm aggregating reachability information and topology information, and I'm actually managing my failure domains in a logical way. Layer 2, layer 3, right? I have Ethernet and I have IP. Why did I do that? Because I'm breaking up a failure domain. I'm actually simplifying the problem by dividing things. Virtualization. Why do I do overlays in data centers? So I can break up my customers from each other. I can break up failure domains. It's always the same set of answers. So my real question this morning is, in my experimental presentation is, why don't we layer the control plane? We have been playing this game for 20 years, and we just munge everything together, don't we? My policy is carried in BGP, and all right, that's my spanning tree picture. That's okay. That's about how I feel about spanning tree. So anyway, we munge our policy into BGP using communities. We munge it into OSPF using community type things, tags, and things like this. And then yet we have the routing protocol doing fast convergence, and we have the routing protocol doing shortest path calculations, reachability. So we've munged reachability and policy and fast convergence and all these things into one thing. And unlike in the protocol world and the network design world, where we split these things up and we thought about the layers logically, we've just munged them all together. So here's my slightly radical question is, why don't we just layer the control plane, right? We have 4 things that I can think of. Now, again, this is not a perfect model. This is all very experimental and something that I've been playing with in my head. And, you know, I'm actually writing a book on network complexity right now, so I've been thinking about this a lot, is that there are a few things that we want the control plane to do. First of all, we want it to handle to implement policy. We don't want it to crash. We don't want it to be spanning tree. We want it to calculate reachability, shortest path, and we want it to be able to react to changes in topology. Those are the 4 basic things that I expect it to do. Okay, so what is policy? I had a slide in here that I took out of Bilbo holding up the little, the little map going, whatever is policy. But anyway, so policy comes in 2 pieces in my mind. The first is data plane policy, which I'm not too concerned about, but I threw this slide in here to be consistent and complete. Data plane policy is anything which modifies the handling of a packet hop by hop, queue depth, things like this, to control jitter, delay, and to do things like deep packet inspection, stateful packet inspection. By the way, the next time I hear somebody say firewall, I'm going to slap them upside the head. There's no such thing as a firewall anymore. There's a bunch of services running on an appliance that you can virtualize out. But anyway, that's my pet peeves are broad and MIDI. So anyway, deep packet inspection, filtering, stateful, load balancing, all these things are my data plane policy. So what is control plane policy? So here's an interesting question. What is control plane policy? So I've looked at all the control plane policy I can think of, and every one of them shares a single thing, or a single common thing that they do. They increase stretch. They take your traffic off the shortest path, or they potentially do. All right, aggregation. What does aggregation do? Aggregation is actually a control plane policy. It's actually removing reachability or topology information out of my network so I can make my control plane converge more quickly and more consistently, more predictably. That's a policy solution. That's not something that you're breaking up your failure domains. This is something you do as a matter of policy. But what does aggregation do on the other side? It actually increases my stretch. So again, or it has the potential to increase my stretch because I have less routing information than I did before. If I look at service chaining, traffic engineering, classic examples, I am actually carrying the traffic off of the best path in order to implement a policy, whatever that policy might be. In the case of a service chain, what am I doing? I'm implementing a policy by carrying traffic through a certain set of services that have been virtualized onto the network, but I'm taking it off the shortest path to do it. I do the same thing when I look at traffic engineering, right? I have this link over here that's less utilized, so I'm going to carry traffic off the shortest path and take it on a longer path so I can optimize my utilization of links over my shortest path utilization, okay? So in any case, what I'm doing is I'm taking things off of the shortest path. And here's a crucial point. How many of you have ever seen a stop sign on a road map? Right, we don't do this. Right? I mean, we don't mark traffic signals and stop signs, no U-turn and no parking on your maps. Maybe you do in some very specialized maps, but by and large, if I go down to Rand McNally or I go down to the map store and I buy a map of Raleigh where I live, I don't expect it to tell me where the stop signs are. I expect to see the stop signs when I drive up to the stop sign, right? The policy is distributed in effect, and it's not carried as part of my reachability. Well, this gives me an idea. If my policy is not the same as my reachability, why can't I just split them out? Why can't I start treating my policy as a separate thing than reachability? Now, of course, policy is going to impact reachability. That only makes sense because, again, control plane policy takes things off the shortest path. So clearly there's a relationship between these two, but they're not the same thing. If I can split these two in my head, then maybe I can actually think of a way of layering my control plane and doing the right thing in the right place. Okay, so centralized versus decentralized. What works really well centralized? A handle to implement policy is the biggest thing. I have not fail up there, but that's a little bit questionable in my mind as to where that falls in the centralized versus decentralized. But nonetheless, a handled implement policy is definitely something that is much easier for me to do centralized. This is the whole game behind OpenFlow and software-defined networking, is that I want to treat all of my reachability as policy, and I want to implement a centralized controller that rolls out all of my reachability. Y'all are looking really confused. I told you this is very experimental. Decentralized, what I think works really well decentralized is I don't think you'll ever be able to beat ISIS or OSPF or BGP in reacting to topology or discovering reachability. Just don't think you can do it. I don't think centralized polling systems will ever beat decentralized routing protocols for finding, discovering, and advertising reachability very, very quickly in a way that makes sense in the network. So here's my experimental proposal following on day. Lower layer determines my reachability, reacts to topology change. My upper layer hides information, engineers traffic and traffic flow. And then I have an ultimate layer, which is my business logic, which actually interacts with my hiding information and my control plane policy. So if I can actually think this through this way, I can actually think about where does it make sense. And by the way, you'll notice I have domain 1, domain 2, domain 3, domain 4 in there. This is again an emulation of Ethernet does the same 4 things that IP and TCP do, but it does it in a different domain. Ethernet does it hop by hop. IP does it end to end. So here's my second kind of experimental proposal. Consider each slice of the network in terms of problem bounding and APIs. The right solution might vary end to end, right? In my data center, it might make sense because my data center probably across my fabric, particularly in the overlay, is probably very, very centered on policy and service chaining. So really I might want to conflate my policy with my reachability in the data center in favor of policy. At the peering AS edge, where I'm actually talking eBGP to a peer, I'm actually going to be the opposite way. I don't have any centralized controller that I can use to push policy across AS boundaries. So I'm probably going to carry my policy within my routing protocol. Within the core, I could actually think about splitting my policy and my reachability. So this is kind of a strange proposal, but I actually think it makes sense that once you look at how you can put these things together and think through what the control plane is actually responsible for and what it's doing, you might be able to divide these functions up and do the right thing in the right place. So Wither, and by the way, Tony, I'm really, really early, but that's okay. No, he doesn't care. Good. All right, so Wither, here is the first thing. First of all, we got to learn to ask hard questions. We're network engineers. And engineers ask hard questions and figure out hard solutions or figure out how to manage the solutions in a way that makes sense. First of all, would we really be better off troubleshooting an API than a distributed protocol? This is actually something that we need to ask whenever we centralize anything, is where does it make sense to have an API to the network and where does it make sense to have a protocol? They're different things, and we're thinking in terms of coders are so good that they've solved all the world's problems and they can slice bread. So we'll just make it all an API. I'm not really sure that really works. So, can polling ever outrun reaction to local events? My answer to that is no. I've been doing this for a long time, 20 years. Now 25 years perhaps. I have never seen polling outrun local reaction to an event. Topology change, reachability, whatever it is. Polling does not beat local reaction. In the world of philosophy, we call this the subsidiary principle. But that's basically what you run into. Should policy always or ever be expressed in terms of forwarding? Well, clearly there is some interaction between forwarding and policy. But is there a way to separate these two things in a way that makes sense so that I can stop thinking about munging them all together? Is there a way for me to overlay these things that makes it easier? Is a unified view of the network actually possible? That's a pretty hard question. A lot of people don't want to hear about it. Are we to the point that with large-scale networks that we need to stop thinking that we're going to be able to understand the network all the time, every corner of it, in every area? I think we might be getting there. We might be getting to the point of using heuristics instead of algorithms. And that just may be the way where we are with this world. And what should we do about failure domains? Look, you know, SDN is a great thing perhaps, And by the way, I do like SDN for some solutions. But what I'm proposing here is that we think about where to use SDN and where to use distributed control planes in a way that makes sense. But if you start thinking about failure domains, when I've connected an entire data center through a single or a pair of controllers, I've just built myself a single failure domain. For 20 years, I have spent doing network design and architecture and doing coding, working in BGP and working in all these other areas. And a rule of thumb has always been split complexity for complexity. Don't build huge failure domains. This is spanning tree, right? Failure domains, large interconnected failure domains are a bad thing. So are we really ready to throw away 20 years of experience in building distributed protocols, breaking up failure domains, and learning how to manage this stuff in order to simply go all the way to centralization? My answer is no to that, but these are hard questions we need to ask. Okay, whither should we go community action? What can we do as network engineers to think through this and think about how we could logically take these building blocks like Legos and build something useful out of them? I always say, vendors are in the rope business. You can either build a hangman's noose or you can build a signal tower. It's entirely up to you. Rope is rope. So how do we take the rope that we've been given and build a signal tower rather than a hangman's noose? So I think the idea is that we need to think through in our own networks. Since I don't own a network, that means you, I guess. But anyway, think through policy. What do we mean by policy? What are we doing with policy? Can we separate policy from reachability? Does this kind of a model make sense? And then we need to push back on the vendors and say, look, we need to think about how these things complement each other rather than just assuming that we're all going to go one direction. Okay, so these things might be supporting Yang and NetConf. Okay, I've said the bad words. I know Yang is the favorite thing of everybody to hate right now, and that's fine. I2RS, but think about ways of pushing. Look, the reason if Yang fails to unify the user interface or the interface in a programmatic way across a large number of devices, the fault doesn't lie with the vendors, as much as we might all like to yell at the vendors about it. It lies with everybody sitting in this room and every other NOG in the world. It's because we're not pushing the vendors, and I say that as a vendor, by the way. We're not pushing the vendors enough to say, look, it's important to have a programmatic interface that allows me to overlay into my network and do the right thing, So anyway, that's one of my other pet peeves for this morning. Think about existing protocols for southbound. Could you use PCEP? We're talking a lot about PCEP at Ericsson and about how we could use PCEP not just as a traffic engineering thing, but as a way to do label stacking for things like service chaining. It's an interesting idea. What are the gaps? What needs to be done? And how does all this fit into open source? Right? These are questions we need to think about and we need to answer. For me, from my perspective, like I said, I've been doing this for 20 years. I've lived through this revolution of centralized, decentralized 3 or 4 times. I'm getting kind of tired of it. And I really think we need to think through how we manage or understand the problems we're trying to address in a better way that actually makes sense. Questions and thoughts? That's my dog looking for the squirrel. And you can download the slides off the website, and those are all the places that I write and places you can get in contact with me if you want to. Has my email address, my Twitter handle. I write for IPJ, all sorts of places. Anyway, lots of ways to get in touch with me if you have feedback or ideas or thoughts, or if you want to throw Rotten Tomatoes offline. Any questions? Questions? No. Okay.
Thanks a lot, Russ. Next up, we have we have a question.
Go ahead, Dave.
Hey, Russ.
Hey, Dave.
Sorry. Dave Meyer, Brocade, U of O. I guess, as you know, I've been doing a lot of work in this area over the last couple of decades.
And Dave, you've been an inspiration to me for that, by the way.
Thank you. One of the things I wanted to mention here is the way you talked about complexity is the way that we always talk about it, as if it's a bad thing. And we've really worked on trying to tease that apart a little bit. And we've gotten to this idea where, so the bottom line here is if you want to have robustness, which we all want, which you were talking about in the latter part of your talk, you have to have complexity to achieve that.
Yep.
It's the gratuitous complexity that you don't want, right? So complexity itself is not inherently bad. In fact, it's how you build. It's a consequence of trying to build robustness in these systems. It's the gratuitous part of it that you don't want.
Yep, completely agree. And that's where I think if we think about what we're actually trying to solve and divide it into pieces, we might actually be able to figure out a way to be the right level of complexity and not too much and not too little.
Yeah, so, we've tried to quantify that a little bit and where it sits today is that you try to understand what complexity is adding robustness and what isn't.
Right.
And that's a hard problem. And I think you're pointing that out.
Yeah.
The other thing I wanted to mention was the discussion you had about layering was really pretty on target. Actually, layering is actually one of the ways that you build the good kind of complexity, right?
Yeah.
And because you can separate and abstract, right?
It's the WASP-based model of IP from original, right?
Yeah, right.
That's right.
Thank you.
Yeah, go ahead, Tony. Tony's going to throw tomatoes at me.
No. I was just going to encourage you to also think about DNS and traffic steering and people sort of moving things, to where they have the control. So,
Right.
if somebody wants to build, I don't know if you heard the talk from Facebook the other day or remarks about how they built a shim layer to,
Right.
To put control, better control the user experience. I think that's going to be discussed coming up. But, it's not just complexity, it's also control of what's the
Right.
part you can
Yeah.
control versus what somebody else controls or what's beyond your control.
So this really comes down to policy dispersion, right? Do you want your policy dispersed throughout your network, or do you want to control your policy centrally and try to centralize the policy, right? And then you get into policy surrogates, and that's another entire craziness. Yep, but I agree. Good point. Now they come rushing to the mics. No, okay, all right, we're done. Cool.
Thank you very much, Ross.